Okay, very good afternoon, students. Today we are going to perform experiment on Zener diode as a voltage regulator. So we'll be performing the experiment of Zener diode as a voltage regulator on a simulative tool, that is a virtual lab that is being designed to perform the experiment virtually using a simulator by which we'll be varying the parameters of your various Zener voltage, your series resistance, your input voltage, the load resistance, and your load voltage. Everything will be measured using a simulative tool of the Zener diode as a voltage regulator. So first of all, we'll be studying the basic concepts and the theoretical concepts of Zener diode and what is basically a Zener diode. Why we need to do experiment with Zener diode and how it regulates the supply voltage. So we'll be performing this and we'll be studying this before starting with the simulative tool. So first of all, Zener diode is what? Zener diode is diode is a special kind of a diode which permits the current to flow in the forward direction as normal. Normally it flows the forward direction, but will also allow it to flow in the reverse direction. It is also flowing the current in the opposite direction of the reverse biased voltage. When the voltage is above the breakdown voltage or the Zener voltage, then that is known as your Zener diode. So Zener diodes are normally designed to withstand the breakdown conditions. Normally the PN diodes can't withstand the breakdown conditions. They are not viable with the high extreme conditions of your voltage. But Zener diodes are so designed so that they can work beyond the breakdown conditions also. So that is why they are known as special purpose diodes. So this is a diagrammatic representation of your Zener diode. Here we have used anode. This is your anode, and this part is your cathode. This is a schematic diagram of this Zener diode. This is the anode, and this part is your cathode. This is the positive end. This part is your positive end, and this is your negative end. So this is how the Zener diode actually looks like. So by performing this experiment, what we are going to understand is we will be actually understanding the function of Zener diode. After performing this experiment, we'll be understanding the functions of a Zener diode. We'll also be able to understand the uh, Zener diode, how it actually Zener diodes works as a voltage regulator. We'll also be able to understand this thing also. Okay, so this is how this is actually working. So let us understand the functions of this Zener diode first. A Zener diode is a special kind of a diode which permits currents to flow in the forward direction. It also allows the current to flow in the reverse direction. Okay, so it allows the current to flow in the forward direction as well as in the reverse direction. When the voltage is above a certain value, this breakdown voltage is known as a Zener voltage. So when the voltage is above the normal or the breakdown level, then it is known to be as a Zener voltage. It is a standard diode. The Zener voltage is high and the diode is permanently damaged. If the Zener voltage is quite high and is beyond a very high voltage, that is Zener voltage, then the diode can be permanently damaged. If the reverse current above that value is allowed to pass through it, if it is specified value, that is Zener value, above that value, if we allow the current or voltage to pass through it, it will be allowing the instrument to get permanently damaged. So we should not allow the instrument to go beyond a certain limits of voltage and current. So in the reverse bias direction, there is practically no reverse current flowing into the breakdown voltage. It is reached when current is actually it is reached when the current is actually coming across. There is sharp increase in reverse current. Varying amount of reverse current can pass through the diode without damaging it. The breakdown voltage, the Zener voltage across the diode remains relatively constant. So what actually is happening over here is when the huge amount of current, when the huge amount or there is a quite fluctuating amount of voltage and current is entering is entering inside your this Zener diode, then what is actually happening is over here, it just try to stabilize it. It just try to stabilize the amount of fluctuating value of the current, and it all allows that fluctuating values to get stabilized with the help of the series resistance RS, and that actually gives us the stabilized level of the voltage. So this is how it is actually working. So this is actually used as a voltage regulator. First of all, it is acting as a voltage regulator because when the level of voltage is beyond the breakdown voltage, it just tries to stabilize it. Stabilize it means it will not let the output voltage increase with the level of increase in the input voltage. It will just try to stabilize it to a certain level of the graph. So that will be actually seen in the simulation also. Okay. So this is a theoretical part of your Zener diode, which we're going to study. Okay. Okay, this is a circuit representation of a Zener diode as a voltage regulator. This is your input supply or the DC voltage, which we're going as an input supply. This is your series resistance. This is your series resistance. This is your ampere meter or the current value that is given as an input. Okay. This is the current value that is given as the output. This is the current value which is regulated by the Zener diode, this Zener diode Z. This is a Zener voltage which we are giving. Okay, this is Zener voltage or which we are providing the Zener. And this is your load resistance. This part is your load resistance. This is your output voltage. Okay, so these are 4 parameters which we are going to vary basically. We first of all we have a Zener voltage, series resistance, and load resistance. These are the basic instructions which we'll be using to perform our experiment. This is the basic instructions which we'll be using to perform our experiment. We'll be setting the Zener voltage to what? First of all, we'll be set the Zener voltage to what? We'll be set the Zener voltage at 5.1 volts. So a Zener voltage is set at 5.1 volt means this is a Zener voltage. So let's set the Zener voltage at 5.1 volts. Let's try to vary this. You can see this, it is being varied simultaneously according to the downstairs. We'll be setting it toward the 5.1 volts. Okay. Now this is your Zener voltage, and this is actually the amount which is being carried, which is 5.1 volt. Now what is second instruction? Second instruction is to vary the series resistance to 1 kilo ohm. So we'll be varying the series resistance to 1 kilo ohm. This is at about 2500. So we'll be varying this at 1 kilo ohm means 1000 ohms. This is your 1000 ohms. Okay. Then the third parameter is what? Load resistance to 2 kilo ohms. Now we'll be putting the load resistance to 2 kilo ohms. So we'll vary this load resistance to 2 kilo ohms. This is your load resistance to 2 kilo ohms. Okay. Now we are left with the voltage, that is the input voltage. Now we have to vary this input voltage from 0 to how much? From 0 to 20 volts. Okay, so we'll be varying this load voltage from 0 to 20 volts. It is, let us say it is at 6.2 volts initially. So we'll be starting with 6.2 volts, or we'll be starting from more below, that is 3.4 volts. Now we'll be adding all these values of input voltage, your series resistance, diode, Zener voltage, your load resistance to the table. Add a table. Now these values have been added over here. Is added to a table. Now we'll be just plotting this value on the graph, and we'll be seeing this. We'll be plotting this value on the graph. We will be setting a plot, and this is your plot values. We have not plotted anything yet. Okay, now we'll be sticking in the set of the Zener voltage. We'll be just trying to vary this DC voltage now from 3.4 to 6.2. Now just add this to a table and just plot the graph again. Okay. Now we'll be taking one more value of this input voltage, add to table, and we just try to plot this. So in this way, we can take the various number of values and we can have the plotting of those graphs. This is actual values which we are taking over here and it is shown over here. Zener voltage is 5.1 volt, resistance 1 kilo ohms, and load resistance is 2. And we'll be keeping all these values to constant and we'll be just varying the in unregulated supply from 3.4, and these other value parameters are being varied from this